Hello everyone, and welcome to this update video. It is September 8th, 2022. Today I'm going to have a small video here to show the progress of my student innovation project. So in the previous video, you've seen that I have the screen working, menu systems going on. I have buttons and lights that work. Today I worked on the power source. Oh, and I apologize, my lab is very messy right now, but I mean, that's the mark of a genius, right? So anyway, let's get down to it. So today I worked on the power source. I have a lithium battery, 1200 milliamp hour battery. All right, hooked up here, and it works. But the problem is, well, how are you going to charge it? Well, I found a way. I have a charger mechanism right here that you can plug in a micro USB, and it will charge the battery safely. And I have it hooked up to this toggle switch, on-off toggle switch, which is a really good switch. I'm going to use it actually in the final project. So here's the thing. So this is only 3.7 volts. You need a lot more than 3.7 volts to power this microcontroller. All right. So here's what I did. I have a step-up converter here. This little thing right here is a step-up converter. It can step it up to different voltages. I have it set at 12 volts. 12 volts runs right into here, and it runs right into the microcontroller right here. So it powers the microcontroller. Okay, so we have a 12 volt rail, right? All right. So now I have other devices. I have this real-time clock here, which runs off of 3.3 volts. So I'm running 3.3 volts off of the microcontroller. So we have a 3.3 volt power rail. Then I also have a 5 volt power rail to power the LED lights, buttons, and so forth. Okay, so far that is 3 voltage rails, right? Well, guess what? We're going to have another one here because this computer right here is very finicky. It has to have the right voltage and the right amperage or it's not going to work. Unfortunately, this microcontroller is not going to cut it. So what I did is I ran the 12 volt voltage rail, all right, and I ran this to a voltage regulator and into the computer, and it worked, okay, but there's a caveat. So this is a 5 volt voltage regulator. So it does power this. It does turn on the computer, but it's intermittent because there is a slight voltage drop with the transistor and the resistor. If you remember Ohm's law, amperage is basically voltage divided by what? You guys know this? Okay, all right. So it is hold on here. So I got to think of the law here. So voltage times resistance equals, voltage. Hold on here. Good grief. I'm tongue tied. All right. So anyway, we're using the voltage laws here for that. So anyway, what's happening here in layman's terms, I can't believe that I'm, oh my God, I'm coming to a blank right here with this. This is funny, guys. This is funny. So, okay. So Ohm's law, right? Voltage, amperage, resistance. Aha, that was the other one, resistance. So we all know voltage divided by resistance is going to give you amperage, or pretty much something like that, right? So what I'm trying to say is because of this resistor and the transistor, we have a voltage drop, right? Which in turn is going to drop the amperage, which is not enough to power this thing full time, so it's intermittent. The solution to that is to upgrade this to a 6 volt system, which I already have on order. It should be here in the next day or two, and that'll take care of that problem. So I'm already anticipating being able to fix that problem. As an added feature, I did start on the rotary controller for this, but I have it on a standalone microcontroller right now for testing purposes. It works good, but there was a caveat. I was having some jumping, and when I looked into it, I found out that this particular set of rotary encoders that I got off of Amazon, although cheap and working good, when you step it up or step it down, it doesn't increment in ones. Okay, so it's not 1, 2, 3, 4. It increments in fours. Each click increments in 4. So it goes from 0 to 4 to 8, onward. So I have to compensate for that. Easy to fix in code, not a big problem here. I should have this working by the end of the week and implemented into the main device. And then after that, it's just basically programming the bells and whistles. you know, doing cool things with the LEDs, making them different colors, you know, having a menu that can change the time, the date, all of that stuff. I've only got 4 weeks left to pull this off, though, guys. So I'm going to keep it bare bones with that and then concentrate on the next step, which is to actually implement the cartridge, which is the main feature of this. So once I get the cartridge done, this should be complete. Right now, I'll say it's about 60% complete. And then we're going to have to design the actual casing and prototype and shrink everything down to SMD, you know, chips and stuff like that, which I have. I have pretty much all of the components. Was not easy with this chip shortage, but I managed to pull it off. So I'm really proud of this, guys. I will have another update video within the next couple of days, hopefully with a working rotary recorder. But for demonstration purposes, let me just show you here that it works. So I turned it on, and as you can see, the screen is booting up, and we have what we want. Yeah, great. Good stuff. Okay, guys. Ciao for now. Thank you. Bye-bye.